Okay, 4.6, 1 through 13, there's proofs on here, so we're going to try to get through these as quick as possible. Similarity and transformations. Okay, so just real quickly in understanding what's going on, we know our transformations. Okay, so you have translation, which doesn't change the shape at all, or the angles. Then we have reflection. Again, that didn't change anything. And then we had rotation, and rotations didn't change anything. The size and shape was exactly the same. But when you get to dilation, the shape is the same, except the lengths of the sides all change. So we can have a right triangle, and let's say this is 30 degrees and that's 60 degrees, and we blow it up, you still have 30 degrees and 60 degrees, but the lengths of the sides still change. So the angles stay the same in dilation. That's similarity, okay? This is congruent, okay? These are all congruent. All right, so now we're just talking about similarity and transformations. Let's go forward. All right, so we're going to graph these. Let's go ahead and draw a nice graph. Start off with simple stuff, just like a review. Let's graph the original first. F is at -2, 2. G is at -2, -4. And H is at -4, -4. So F, G, and H. So we'll do the main one in blue, or excuse me, in black. All right, it's a right triangle. So now, what are we doing to it? Let's do the first thing here. So we'll do this one in blue. So we're going to go to the right 3 and up 1. So 1, 2, 3, up 1. That's G. 1, 2, 3, up 1. That's H. Prime. And F is up over 3. 1, 2, 3, and up 1. So that's F prime. So that is a rigid motion, meaning it didn't change shape. Okay? So that's translation, but now we have dilation. We'll do this in red. We're going to take those values and multiply them by 2. So what are those values first? Let's see here. So F prime is at 1, 3. G prime is at 1, -3. And H prime is at -1, -3. Now we'll multiply those by 2. And we're going to get F prime, double prime, is going to be at 2, 6. G double prime is at 2, -6. And H double prime is at -2, -6. We just multiplied everything by 2. All right, so let's plot these. 2, 6 is F double prime. G double prime is at 2, -6. Okay. Wow, good drawing. -2, -6 is H double prime. So that should be your answer, and that's definitely on the test. Okay, let's go ahead and graph these. Do the same type of thing. Let's do black. All right, F is at -2, 2 again. G is at -2, -4. And H is at -4, -4. So same picture. And now we're dilating first. So we're going to take 3/4 of each of these values up here. So here's the trick. Multiply by 3 and then divide by 4. And that'll make you go faster. So we'll do this in blue. F prime multiplied by 3 is -6 divided by 4. -6/4, which is -3/2. And 2 times 3/4 is +6/4. G prime multiplied by 3, we get -6 divided by 4. And -4 times 3, -4 times 3 is -12, divided by 4 is -3. And H prime. Okay, these are going to be -3 and +3. So let's plot those. -6/4 is -1.5, -1.5. Okay, and up 1.5. So there's F prime. G prime is at -1.5, -3. Just right there. And H prime is going to be at -3, -3. So it shrunk it. Okay, and now we're reflecting in the x-axis. Ugh, this is tough. I'm going to blow this up and reflect. So this will be in red. F prime, reflecting in the x-axis. So yeah, F double prime will be there. G double prime is 3 units on the other side. Okay. Let's make this thick. Okay, and H double prime is 3 units on the other side. 1, 2, 3. So that's the flip, the reflection of our figure. There you go. Next. All right, number 7, determine whether the polygons with the given vertices are similar. Use transformations to explain your reasoning. So let's just look at A and D here. We're going to assume that alphabetically, meaning that this would be A prime. 6 and 0. Well, obviously it flip-flopped and y is half of the x. Does that work with E and B and E? Half of 9 is not 5, and they didn't flip that. So let's graph it and see if visually we can figure out what happened. Okay, so 6, 0 is A, 9, 6, 1, 2, 3, 4, 5, 6 is B, and 12, 6, okay, or 8, 12, 6, okay, is C. So here's our ABC, and I'm going to do primes from here. So we'll say A prime is at 0, 3, and B prime is at 1, 5, and C prime is at 2, 5. 2, 5, C prime. Okay, well, they definitely look similar. Let's just look at our slopes and our distances. B to C prime is 1 unit. B to C is 3 units. Okay, and they're horizontal, so the slopes are the same. Let's look A prime to B prime is up 2 and over 1. How about A to B? That's up 6 and over 3. Those are the same slopes. But we got to check C. A prime to C prime is up 2 and over 2. And A to C prime is up 6 over 6. Okay, so the slopes are all reduced by 3, basically. 3 divided by 3 is 1. 6 over 3, reduce it by 3, you get 2. And 6 over 6, reduced by 3, you get 1, which is 2 over 2. So the slopes are all the same, and your distances in the way we've looked at are the same. So your angles are the same. So it's a similarity. They're definitely similar. All right. Use transformation. Oh, so the last one was a dilation, if you wanted to know. I think that was obvious. Okay. So here, let's go ahead and graph these. Negative 2, 3 is G. H is at 4, 3. I is at 4, 0. And J is at 1, 0. So wait a minute, let's draw that. That's GHI. That's terrible. J is at 1, 0. Again, you can change that to G prime if you want. K is at 6, negative 2. And L is at 1, negative 2. So it looks like that's a right angle, that's a right angle. But what is L to K? 1, 2, 3, 4, 5. H to G is 1, 2, 3, 4, 5, 6. So that's 5 units, that's 6 units. Okay, H to I is 1, 2, 3. L to J is 2. All right. So what do we get for our slopes? Those are vertical and horizontal. What about the slope from I to G? So it goes down 1, 2, 3 and over 1, 2, 3, 4, 5, 6. So negative 3 over 6. What about I to K? Is down 2 and over 5. So negative 2 fifths. So the slopes are definitely not the same. So since those slopes are not the same, that changes a whole bunch of things. Okay, the other thing you could do is to see if they're similar. You could do the sides. So GH6 is to LK, as HI3 is to LJ. That's definitely not the same. Okay, so they're not proportional and the slopes aren't the same. So these are not similar. All right, let's do these proofs. This is important. You blow these off, you're going to hurt yourself. Okay, so what do we have here? Our given, we have right isosceles. So I'm just going to write given here. You don't have to write the whole thing there for what it is. This whole thing goes right here. Okay, so that's your given. You have right isosceles in ABC with leg length J. Okay, so that's J and that's J as well. Right isosceles RST with leg length K. And that means that's K. That's what those hash marks mean. All right, and that's what isosceles means. Remember, whenever you start to say that's what it means, that means definition by whatever you're saying. And it says CA is parallel to RT. Okay, so you have the little parallel symbols right there. Okay, we're trying to prove that ABC is similar to RST. Okay, so if they're similar, then all their angles are the same. Okay, that's all you need to show is their angles are the same. Well, we already know that angle A and angle R are equal. So angle A is equal to angle R. Definition of right triangle. Okay, and since your legs are the same, then opposite angles are the same, which we had that. That's the base angles theorem, or isosceles triangles have base angles the same. Okay, so you have angle B is equal to angle C. That's what definition of isosceles. Okay, and the same thing on the other side. You have angle T is congruent or equal to angle S. Same thing, definition of isosceles triangle, but base angles are the same. This would be the converse of the base angles theorem, so technically I guess that would be what you would have to say, but this is okay. All right, so what we're showing here, just briefly, is that those two angles are the same. We already know that is the same as this one, and we know these two angles are the same to each other. The question is, are these two angles and those two angles the same? Okay, so we have parallel lines here. Okay, so the thing is, this is 90 degrees here, and that's 90 degrees, all right? So those are both 90 degrees. There's 180 degrees in each triangle. So that means there's 90 degrees left between the other two. So that means that's 45 and that's 45. Well, the same goes for this triangle. So they have to be the same. So how do we say that? All right, so the triangle sum theorem says they have to equal 180. We already said that the angles are the same. All right, so you can sit there and say that angle B plus angle C equals 90 degrees, the measure of these. All right, and the measure of angle S plus the measure of angle T equals 90 degrees. So by the transitive property, you have the measure of angle B plus the measure of angle C equal to the measure of angle S, all right, C, plus the measure of angle T. That's transitive property. All right. So therefore, everything's by substitution. I can say the measure of angle C plus the measure of angle C equals the measure of angle S plus the measure of angle S. So basically, you have two measure of angle C's equals two measures of angle S. Divide off the two, the measure of angle C equals the measure of angle S, which is what we were trying to say. All right, so this is all substitution, And if you have your angles the same, the measurements the same, then angle C is equal and congruent to the angle S. And now you have all your angles. So that's similarity theorem, that all your angles have to be the same. Okay, this is angle addition up here. I didn't put those in. Okay. All right, now what they do wrong here, describe and correct the error. Determine whether the figures are similar. Okay, they said figure A is similar to figure B because figure A can be mapped to figure B by dilation with a scale factor of 1/2. Okay, well, A to B, what are the, let's do this point right here, these 2 points. So 8, 6, if we take half of that, then A prime should be at 4, 3. And it is. Okay, well, let's do the next one. We'll call that A and A prime. Call this B and B prime, and C and C prime. Well, B is at 14, 6. And so B prime, half of that should be at 7, 3. Is that where it's at? No, it's at 8. Let's see. Yeah, B prime's at 8, 3. So that's not right. Something has happened. So they made a mistake. They're not similar. And C to C prime, just to do it, C is at 8, 2. If we take half of that for C prime, we get 4, 1. And we do have 4, 1 for that. So B doesn't go to B prime correctly. So it's not by a scale factor of 1/2. So that changes your degrees. Okay, enough of that.